In this lecture, we are going to discuss about how to implement the boolean function using 8x1 multiplexer. So the 8x1 multiplexer is here we are having now that 8 input, right, and 3 selector line, and we are having one output, right? So here what you mean by that one is depends on the selector value, the corresponding input pin is allowed to as a output. So this is a multiplexer function. Now, this function is going to be used to design the Boolean function. How it is? We'll see that one. First, we are having now 4 input A, B, C, D. So you are writing the 4 input A, B, C, D, and then you have to give the binary value for 0 to 15 you have to give. Right? Then you have to write that output. Right? Output is whatever that value. This is sum of min-term. 1, 3, 4, 11, 12, 13 and 15. For that number, you have to put value 1, right? 1, 3, 4, 11, 12, 13, 15. So you are giving now that one, right? Then here, this is actually 8x1 multiplexer. 8 is, we are having 3 selector line. So the 3 selector, first 3 input, first A, B, C, D, first 3 digits, right? So from MSP to the 3 digit is connected with the selector line. And fourth is, here we are going to use for the output. So here, now what we are having now? For that F. So if you are having, this is the 3. See, selection is only 000. For the 000, then the output is depends on T. So directly we can have now that 0 and 1, 0 and 1, then you have to directly connect with them, right? D 0, right? So that 0, then if D is 0, then this is allowed, 0 is allowed as output. So D equal to 0, then the output is 0. So because 4 zeros are, output is 0. Right? If it is 1, then this is allowed as output 1. Right? Now we are having now 0, 0, 0, 0, 0, 1. For that we are having output is 1. Next we are having now that ABC is 0, 0, 1. So that is here the selection is 0, 0, 1. 0, 0, 1. Then here also the output is depends on the D value, because D is 0, F is 0. D is 1, F is 1. So that one we can directly connect with D for this one selector. For this one selector, then directly you can connect with that. So the function is F equal to D. F equal to D. Why it is? This is the case, right? So D equal to 0, F equal to, D equal to 1, F equal to 1. So that function is F equal to D. So here also D equal to 0, F is 0. So this is 1. So that one is F equal to D. Next, here we are having now, the selection is 2. Selection is 2, 0, 1, 0. And then we are having that one for 0, the output is 1. For 1 is output is 0. So that this is actually inverted. So F equal to D dash. So the D is inverted. So in that selection line is 0, 1, 0. Then here these two should be inverted and you have to connect with T dash. Right. Then here next one, here we are having for 3. For 3 as a selection line. And then if this is the whatever the D, but the output is 0, 0 only. So we can directly connect with 0. So at the time of this selection, the output 0 is the 3. 3 is 0, right? Next one, here we are having now that in that case, this is selection line is 4. If D is 0, F is 0, and D equal to 1, F. So for both cases 0. So directly you can connect with the 0 line for both. Right? Then we are having for fifth. Fifth, what it is happening now? This is 0 equal to 0, 1 equal to 1. So directly we can write the function is F equal to D. So directly you can connect with the D line. So fifth is connected with the D line. Then Here we are having now, this is 6. For that case, then for 0 and 1, here we have to output is 1. So you can directly connect with output 1 line. So this is 1, right? Next, we are having now for 7, here we are having now the 0, 1, then the output is corresponding. So that is F equal to T. So in the T line, you have to connect with 7. Now, the circuit is the implementation of Boolean function, this one, through 8 cross 1 multiplexer. Here, you are having the corresponding function name is F derives. F is depends on either D or D dash or 0 or 1. Then you are finding now, then we have to get it now. Next one, the same method. Then another question in that examination, they ask the question. Realize the function M0, 5, 0, 1, 5, 8, 11, 14, and 15. Now you see this one. How do you do that one, right? So that is here, as it is here, that F value is changing now, right? The 0 is 1, 0 is 1 is also 1. Then next 2 is 0, 3 is 0, 4 is 0, 5 is 0, 6 is 0, 7 is 0, and 8 is 1, and then 9 is 0, 10 is 0, and 11 is 1, then 13 is 0, 14 is 0, 15 1, 14 is 0, and 14 is 1, and 15 is 1, right? Now, how do you write the functionality? Here, F equal to 1. So, F is connected with 1. F equal to 1. Then here we are having now all are 0. So F equal to 0. F equal to 0. Then here all are 0. F equal to 0. Here all are 0. F equal to 0. Right? Then here we are having now inverted. So F equal to D dash. F equal to T dash. Inverted to T. So that is 0 now 1, 0. So F equal to D dash. Next here we are having 0 to 0, 1 to 1. F equal to D. Then here we are having now 0, 0. So F equal to 0. F equal to 0. Then here we are having both are 1. F equal to 1. So how do you draw the circuit is? Here first one is F equal to 1. Right? So that is 1 is connected with 0, and also here we are having 1 is connected with 0, and okay, 0 is connected with 0. Right? 1 is connected with, here 1 is sorry, 0 is connected with 1 because F equal to 1. Then 1 is connected with 0. 1 is connected with 0. So the 1 is 0. This is 1. Right? So now you are having now this is 1. Next, here we are having now this is for 2, 0. So the 0 is connected with 2. I'll draw the diagram once again. Here the 0 is connected with 1. So 0 is connected with 1, and 1 is connected with 0. 1 is connected with 0. Next we are having D is there, right? So D value. So 1 is connected with 0. Then 2. 2 is connected with 0. 2 is connected with 0. And 3 is 3. Is the 3. 3 is connected with 0. So 3 also connected with 0. And 4 is connected with D dash. So you take that 4 is connected with the D dash, right? So this is a D, then you have to connect with the D dash. Inverted. 4 is connected with D. So this is 3. And 5 is, so that this is a value 5, 5 equal to 0. So that 0 line is connected with 5. 5. And then 6 is, we are having that this 5, 6 is 0. Or sorry, 5 is connected with the D. 4 is connected with the inverted. This is 3, and 5 is connected with the D. 5 is D, right? And 6 is connected with 0. 6 is connected with 0. And then 7 is connected with 1. So this is the 1. 1 is here, right? So 0. 1, sorry, இது connected. Okay. Is connected with 0, right? And 7 is connected with 1. So this 1 is connected with 7. This 1 is connected with 7. Okay, so that is here f equal to 0. This is f equal to 1. First one, f equal to 1. And this is f equal to 0. And this also f equal to 0. This also f equal to 0. And 4 is f equal to d dash. And 5 is f equal to f equal to 5 equal to f 5 equal to 5 equal to f is 0, right? So f is 0. And 6 equal to 5 equal to is 0. 5 equal to f 5 equal to f is t. Sorry, 5 equal to 5 equal to d. And 6 equal to 0. F equal to 0. And 7 is f equal to 1. So this line should be drawn here, right? In that place, instead of this one, we have to draw this one for this problem, right? So because of this number, we have to put the corresponding number, and then you have to write this formula here. This is the okay. This is the function for each input line, right? F equal to 1. This is f equal to 1. F equal to 0. This is both are 0, so f equal to 0, right? And then here, this is f equal to 0. So here both are 0, f equal to 0. Then this also both are equal to 0. Then f equal to 0, right? Then here we are having f equal to d dash. Because 0 to convert it into 1, 1 is converted into 0. So f equal to d dash. So you put it now, f equal to d dash. Next one is 5. For that 5, we are having 0 to 0, 1 to 1. So directly we are getting now d. F equal to d. F equal to d. So that is here. F equal to d. And here we are having for 6. 6 we are having now. Both are 0. 0 means directly you can connect with 0. So that is f equal to 0. Here both are 1. So directly you connect with the line 1. For this particular 7 selection, the line is 1. Then you have to get it that 8x1 multiplexer circuit for realizing this function with that number. That's all.